right? So I know that this is going to turn into a single log, right? Big old log right here. And it's going to have division like this, right? Yes? And what goes on top?
X squared plus 2x.
All of this, right? You want to factor that? We're going to have to, yes. Yep. Over the bottom. All right. Does everyone agree with that's just the property, right? That's just the property 2, the log property 2 right there. But when you have a fraction over a fraction like this, right, this is really multiplication of the reciprocal. So this really turns into log, it'll be x squared plus, oh, well, yeah, plus 2x minus 3 over x squared minus 25 times the reciprocal of the bottom, x plus 5 over x squared plus 2x minus, no, x squared plus 7x plus 6. So division is the same as multiplication of the reciprocal.
Don't you factor?
Don't.
No, that would
No.
be expanding.
That's right. If you were going to, you could split that up, but we're trying to get it all down to one log. We've got it down to one log, don't we? But we just need to simplify what's inside, that's all. So now we notice we've got some quadratics in there, and they all factor. Well, most of them. No, we don't leave it like that. So
X squared minus 25 is x plus 5, x minus
that's right. Oh, wait, what is this? Hold on.
Just wanted to make sure I got one in there.
Is that it like that? Did I get that factored correctly?
No. Do it again. Why? It only took him 15 seconds.
That's it, right? Yes. I only see one thing that cancels. Do you? Yeah, that's it. I was hoping more would cancel, but that's all.
What about the x plus 1?
That's an x minus 1. So you don't have to multiply it back together. You could. It's not incorrect to multiply it together. You can leave it x minus 1, x plus 3 over x minus 5, x plus 6, x plus 1. There you go. We good? Okay.
So when is this going to become complicated?
If it's not complicated yet, you're good to go.
Yay!
All right? I can make it complicated if you'd like to see complicated.
Yeah, I'm challenged.
Well, let's do baby steps, all right? Let's walk before we run. All right. How about this one? 3 log base 5 of 3x plus 1 minus 2 log base 5 of 2x minus 1 minus log base 5 of x minus 1/2 log base 5 of 3x plus 1. That's it. Now, you have to be extremely careful with this. You want me to let you mess with it for a minute?
Yes.
Yeah, let you mess with it? All right. Just going to say be careful. We want to condense this. That's what makes this one a little bit hard. I want to see what you do, and then I'll show you the proper way to do it. Hmm?
Can I put how the exponents will
Mm-hmm. You would do that first? Yeah, I would do that first.
All right, just got done writing.
Writing it down? Okay.
Maybe.
You're going to need to look at, you got to be careful with that. Yeah, you're going to have to be a little careful with that, with those signs.
So it does have to do the brackets here, and then distribute. Well, it'd be a positive, which would
Yeah,
make it
if
a
you're going to put a bracket,
multiplication.
if you're going to put a bracket around that, look at it as almost like you're factoring a negative one out of these.
Okay.
Okay? And so you'll have a minus, and then your bracket, and then you'll have one of the logs, and then you'll have plus the other log, right?
Right.
Put those together, and then come in with your division. I'll come over there.
I'm right here.
That second one's not right.
This?
This one right here. These to here, it's not. You do have subtraction between two logs, but look, you've got a negative on the first one.
So that's going to go to that, and a negative 1 to that? Or does
I'll give you the same hint. Why don't you factor a negative 1 out of both of those? Like this. Those last two logs, factor a negative out. Rewrite it with where they're both positive. Put those together. And then, yeah, I'm coming. I'll be here in a second. Hold on, they were first.
So I have this so far.
Yep. Mm-hmm.
Okay.
Good so far.
Okay.
Get the same place?
No.
No?
I give up. I'm honestly, I'm just.
You're just not feeling good? That's how I felt yesterday. It's going around. I think it's only like a 1 or 2 day thing, though.
Yeah, I hope so. I could not sleep last night
Yeah.
at all. I was like dying.
Okay, well, try and hang
But I
in there.
came.
You're here to get everyone else sick. Thanks, appreciate that. I'm kidding,
I don't
I'm
want
kidding.
to watch your, I just want to be here
I
because I
know.
get to ask questions.
You're on the right track.
Class, I have a member list.
Did you try it? Are you stuck?
Oh, no, I kind of just...
Kind of zoning out? All right, try it. This one's a little harder.
Yeah.
I just want to do like that one on top of.
Oh, I said I would come here next, sorry.
Well, I messed up because I had this plus the whole time, so
Oh,
I ended up
okay.
with that.
Okay, yeah, there's something I think a little off. I don't think anyone's got it yet. Now, you seem to be on the right track here.
So just take the first one and then first one over that one and then start doing the reciprocal of each one. That's where it's going to keep dividing, so just multiply yourself.
And you got the 3x. Okay, and then you added. We'll see what this last one turns into. I think you're right on track there. You've got a 3x plus 1 to the third.
Yeah, had that. And then since there was one on the bottom, I canceled it out to become a square.
Okay, let me work it out. We're going to see where this goes.
It's on the right track. You just put the exponents in.
Put all the powers up first, yep.
Yeah. And now I want to put like that one on top of that one on top of that one.
Yeah, that's where we are. That's where everyone is, like what to do with that. Okay, so look, let's go through this.
That's only on the second part of the
All right, you ready? Because this is there's something really subtle in here you have to be extremely careful with, all right? I think most of you decided to put all the powers up first, which is the correct first move.
All right, we're done. And that's as far as I got. I don't really know, but if you were to ask me about that first step, I would tell you all about that first step.
So we're all okay with that step, right? Now what I'm going to do is I'm going to work from left to right. I'm going to put these two together first, right? What are those two together? A single log, right? Log base 5.
3x plus 1 to the third over 2x minus 1.
All right, that's the first two together, right? Now there's more than one way to go about this, all right? There's more than one way. I'm going to do it the way that I would do it, which is a little different than the way I showed you, because you were already telling me that they were both negative. So I was kind of going with your thought process. But look at this. Do we not have two logs being subtracted again right here? So shouldn't I get that into a single log with this over that?
Yeah.
Yes? Okay, so let me do that. So watch what happens here. This is going to be a single log, base 5, of, now be careful, what over what here? Everyone? It's all of this. Okay, let me write that down. 3x plus 1 cubed over 2x minus 1 squared. Over what? X. What the hell is that, though? You know what I'm saying? What? You can't. Stop, hold on. What? Nothing. That's exactly what I'm going to do next, yes. Because this is what we call a complex fraction, right? This is just a fraction over a fraction. That's all it is?
Yes.
So instead of doing, this divided by this, why don't we take this and flip it? Which means the x would really be where? On the bottom, wouldn't it? Right? If I flip this, this becomes a 1 over x right there, multiplied. So I'm going to write the next line out without doing anything else. I've taken care of all this, though. So here's where I am. I'm at log base 5 of 3x plus 1 cubed over, and I'm going to put that x down here just in front, x, then 2x minus 1 squared.
Where did you get the original x over 1?
I already erased it. It was the line right before.
Oh,
It was the log x, log base 5 of x.
okay.
And I was subtracting that, so it became the division part. Is everyone clear on this? And now I've got minus this one again, right? So I can do that again. So this should turn into a single log, right? Okay. Okay, so this is going to turn into a single log of what divided by what?
All of that,
All of this divided by
the square root.
the square root thing here, right? So how about this? 3x plus 1 cubed over x times 2x minus 1 squared over 3x plus 1 to the half.
Would you not put that in the square root?
I'm not, because I have another 3x plus 1 to the third up there. You see it?
Where?
Yes?
You don't? Wait,
I'm not done, but
oh.
yeah. Are you okay with that so far? I have a fraction over a fraction.
So would it mess it up if you did the square root earlier on?
You could, but you would want to realize that you have it again up here. You might not see that if you...
I did it like
So can I do that fraction over a fraction again and flip it? Yes? Which becomes, what, when I flip this, where does this 3x plus 1 to the half appear? On the top or the bottom? On the bottom, right? So I'm going to rewrite that whole thing to be log base 5. I've got the 3x plus 1 to the third over, I had the x down there, the 2x minus 1 squared, but then this guy just joined it, 3x plus 1 to the half. Not going to square root, because look at this right here. You see this? If I asked you what x cubed over x to the half was, right? Wouldn't you do x to the 3 minus a half? Properties of exponents. If I said what's x to the 7th over x cubed, wouldn't everyone in here say x to the 4th? Yes? Because you would do 7 minus 3 is 4? So if I have x to the third over x to the 1/2, you would do 3 minus a half? So if I have 3x plus 1 to the third over 3x plus 1 to the half, you would just subtract exponents there also?
Sure. If you really want to.
Why? Well, I've already passed that step. It was a minus. I had minus log.
So we made another fraction.
So I made another fraction using property 2 again.
So we cancel out the 3x plus 1 at the bottom, and then make it 3x plus 1 to the 2.5.
So it stays like that, you don't actually.
No, I'm actually going to do it right now. I'm not done. So here's my final answer. When I put these two together, and I actually subtract 3 minus a half, I get how many? I get what? As a fraction, though. As a proper fraction. 5 halves. 5 halves.
Does that?
Hmm?
Say as an improper credit?
I said, when you're, okay,
Stay on the numerator?
you're saying this versus this, right?
Yeah, it's a perfect.
Mixed fraction,
Yeah.
mixed numbers,
2 times 2 plus 1.
proper fractions.
Oh, it's proper.
Look, throw these out of your repertoire, okay? Just get rid of those,
You know this.
all right?
If you don't use mixed fractions, you can't.
I don't know what they say about that. But I can say this, if you open up any calculus book, you'll never see a mixed number in there. It's always, well, maybe in some ridiculous exercise in the back for some reason, but all the work that they do in a calculus book is always done with this. You never use these.
No mixing of the fractions.
Yeah, don't mix them up. Segregate the mixed from the proper.
Separate but equal, right?
All right, so this is going to be 3. They are separate but equal. Yes, they are. They are equivalent, but they're not. We just don't mix them. Okay. Hey, you brought it up.
I was so close.
That's the correct answer.
So you always keep it on the numerator?
No, I only keep it in the numerator because 3 minus a half is 5 halves. So look,
If it would have been 1 half on top and 3 on the
look, yes, look, if you would have done this, well, do it this way. What do you get if you do x to the 4th over x to the 7th? It's x to the 4 minus 7, right? Which is x to the negative 3, which brings it to the bottom. All right, this is the correct answer. You have a homework problem similar to this problem. All right? The last little thing here in this section is, yeah.
So would you think it would be easier to do it that way because we did it that, seeing it as that way?
I don't know, I think it's easier that way, so you don't have to worry about mixing up your.
Well,
That's the way I
it's,
originally thought.
however you want to do it. Watch, let me ask you this, okay? Let me see. I'm just going to put this up here just to see if this brings any clarity to you. It may not, all right? You're going to have to help me. The original problem, what was it? We had a 3 out front first?
Yeah.
So log base 5. And we brought it up, right? Is everyone paying attention? Well, look, if you had trouble with that one, you might want to pay attention to this. We all had gotten to that point, right?
Plus 1.
Oh, plus 1. We'd all gotten to this point? Yes? Okay, let me just ask you something here. What is the number sitting in front of this log right here? Negative 1, the number right in here? Negative 1, the number right in here. Negative 1. Just see if you agree with this. Is this the same thing? Is that the same thing? Yes. Everyone see that? Look, if I bring this down, I get negative 1/2 in front, negative 1 in front, negative 2 in front, positive 3 in front. That's the same problem we started with? Yes? Now, do you notice that we have addition, addition, addition between all the logs now? Couldn't I then just put these all together into a single log with multiplication?
Yes.
Okay, so this would be log, a single log, base 5, and then all of these things multiplied together. So I would have 3x plus 1 to the third, 2x minus 1, or yeah, 2x minus 1 to the negative 2, x to the negative 1, 3x plus 1 to the negative 1/2. Do you agree? Okay, now anytime we see negative exponents, we like to do what with them? Drop them down. So this one will drop, right? And that one will drop, and we'll be exactly where we were on the second to last step that we just had.
So pretty much you're skipping all the way.
I'm skipping all the division by changing everything over to positives. You can do it that way. It's not wrong. Also, we could at this point put these two together. But since these are next to each other, it's not division. What do you do to the exponents if you have something like x to the 4th times x cubed? You add them, right? So if I add 3 and negative 1/2 together, I get 2.5. Not 5 halves, 2.5. No, it's 5 halves, right? I'm just trying to confuse you, Nathan.
So as long as we end up with the same answer, we're good.
That's right. So if we do this, we could get log base 5. We had the 3x plus 1 to the 5 halves. That was the only thing left on top, right? And then these two drop down. And that's the same answer we just got. I'm just showing you there's more than one way to do it. The books always do it with the division. They always use the property where they use the subtraction to division. I'm just trying to point out that if you're ever having trouble with that in a problem, you can always convert these minuses to pluses as long as you remember that these powers are negative now. All right.
Still waiting on these to get hard.
Okay, how about this one then?
No.
I'm going to blow you out of the water right now. Here you go.
We have 2 minutes.
It's over. There it is. This is the last part of this section. Find log base 518.
Oh, I know this. I don't.
All right, so at the end of last class, I introduced you to something called the change of base formula. And I said, remember, you can use a calculator now to solve logs. I said, I'm giving you this early because it's actually from the next section. So this last part of the homework assignment is just use your calculator to figure out what these are. So what am I going to type into my calculator here?
0.556827. Or actually, no.
That's what I'm going to do on my calculator? Or log. You can also use the log, the LOG key. But And you use your calculator. 1.7959. You're confused what? Okay, yeah, because you weren't here last time. This is why. Because we have a formula from last class. It's called the change of base formula. And and look, I'm not even giving you a hard time. They're giving you a hard time. You see? So anytime.
I expect this from him.
Yeah, there are certain things we can't do. I mean, this question right here is 5 to what power is 18. We can't figure that out. But this formula allows us to do it. And all it requires is that our calculator has this key on it, which it does. So if you just get on your calculator, natural log of 18 over natural log of 5. Oh, that reminds me. Calculator quiz today. Who's going to sacrifice a piece of paper?
Shut your mouth.
The what?
Calculator quiz. Okay, you may put your name on this.
Just on the first line?
Yep. Thank you. Nathan, you can sign. Jasleen, what?
She has one.
That's.
I was being a good friend and let mine out of my hand.
I'm going to let it go.
So do I get this quiz grade twice?
No, you have to do.
So this was fun, right? So I originally did the division, but then I grouped that together and did that
Yes.
multiplication. and then
Did you come up with the same result?
Yes.
Everyone has calculators here?
Yes. Oh, yeah.
Yes? If you have a calculator, you may put your name there.
I always have my computer.
Okay. Yep, okay. I said last class, I'm going to do a quiz, and if you don't have your calculator. What's this? Yeah, next one. Next one, next one. David, do you have your calculator? Okay, not your phone. Look. Well, I know your phone has a calculator, but you can't have it. That's what I said, you can't use your phone. Look. If he breaks it, he can fix it. He's got this, he's magic over there, all right? See, broken screen, not broken screen. You can't use it on a test. So you have to have something that you can use. I won't take off because you weren't here yesterday, but the warning was on the video.
Yeah, there was a warning.
Everyone has it, so everyone just make sure you sign in.
18.
All right, so you think you can handle that? Yeah?
It was shortly after our insult.
Where are y'all going? We've got 13 minutes. I know, but I had one more thing.
Yeah, he said he was going to blow our minds.
Everybody likes bonus, right? Yes. Okay. So here's a bonus question. It's bonus, so if you don't want to do it, you don't have to, all right? But you have to do it right now, and you cannot work with anyone else. You have to do it on your own. You can use your notes, you can use your calculator, you can use your book. You just can't help each other, okay? Is that clear? All right. Show natural log the square root of x plus the square root of x minus 1 plus the natural log of square root of x minus square root of x minus 1 equals 0.
So we're condensing.
I can't answer that, sir. You just need to show that this left side is actually equal to 0. You're welcome to do it. If you don't feel like it, you can pack up, you can leave. Did everyone sign in? Where's the sign in? Everyone signed in?
The sign in or the calculator?
Well, everyone has their calculator except for David. But I'm not going to count off.